Are you ready for the Unit 5 test? In this problem, we're going to start by rewriting this equation in vertex form. This is called standard form. Vertex form will be in this general form. So the first thing I'm going to do is I'm going to replace g of x with y. You are going to be asked to show all of your steps. Simply writing down and rewriting this in vertex form without steps will not provide you with any credit. I'm going to take the constant and move it to the opposite side. Whenever the leading coefficient is any value other than positive 1, I'm going to factor it out. 2 times 1 is 2, dropped on the x squared. 2 times negative 6 is negative 12, dropped on the x, and now we have this blank spot. How do we achieve this number? We take the b value and the sign, always divided by 2, and square it. Negative 6 divided by 2 is negative 3, and negative 3 squared is positive 9. Now, to keep the equation balanced, I need to identify what value was just added to the right-hand side. It was not 9, it was 18. If I add 18 to the right, I must also add 18 to the left. Negative 23 and positive 18 results in a negative 5. And now I could ask you to come off to the side and to factor this trinomial inside the parentheses. But a quicker way is to take this parenthesis, drop it down with an x in front of the value and the sign. Lastly, we move 5 back to the other side, and I have y equals 2 times the quantity x minus 3 squared plus 5. These are equivalent but in different forms. Next, we are asked to sketch a graph of this, so I'm going to take out my graph paper, and I'm going to start by going to the vertex, which is at 3, 5. 3, 5. So the vertex will lie to us on the inside and tell the truth on the outside. So I'm going to find 3, 5. Okay, over 3 and up 5, 2, 4, and 5. Okay, so I've identified what the vertex is. It is at 3, 5. And next, I'm going to remind myself, and this will not be in the board, the parent function to quadratic equations has the order pairs of 4, 1, 0, 1, and 4. Why? Because negative 2 squared is 4, negative 1 squared is 1, and so on. How can I use this when I'm looking at the equation y equals, and let me move this, when I'm looking at the equation y equals 2 times quantity x minus 3 squared plus 5. Well, any value that's directly out in front of those parentheses will always be multiplied by the y's. So this becomes 8, 2, 0, 2, and 8. So from here, this is my 0, 0. From here, I'm going to go 1 to the left and up 2. Then I'm going to go 2 to the left and up 8. 2, 4, 6, and 8. 1 to the right and up 2. And 2 to the right and up 8. So I've graphed the function. I do need to identify on paper what is the vertex, which I've done. I also need to identify what is the y-intercept, and in standard form, the constant up here is going to be the y-intercept. So 0 and 23. Last, I need to show how do we achieve the zeros by hand. So the zeros are going to be the x-intercepts. And when we find the x-intercepts, y is always 0. I like to use this form. Now, if this confuses you, feel free to go up and look at this original function and see, is it factorable? Because you can solve by factoring. Sometimes you could always use the quadratic formula. All right, so I've set y equal to 0. And here we go. We have negative 5 equals 2 x minus 3 quantity squared. Before I go any further, I want you to keep this in mind. When we're solving for the x-intercepts, we've already graphed it. And look, our parabola never crosses the x-axis. And that tells me right now, as I'm showing my work, it tells me that I should come up with an answer that doesn't make sense. And here it is. At this point, I know I cannot take the square root of a negative value and get a real answer. And so there are no real solutions.